Okay, we gave example that if you have any of this model and you need to predict y, and you are told that x is a particular value, find y when x is 20, for example. To use this first model, we are going to put the 20 to replace x here. We find natural log of 20. Use it to multiply 13 and add it to 39. Whatever we get is the value of y when x is 20. To do the same thing under the power function, we'll put the 20 here and raise the 20 to the power of 0.0169. We get a result. We now use the result to multiply 45.96. To use this exponential, we put the 20 here after the power. We use it to multiply 0.021. We get a value. We now take exponential of that new value. We now multiply the result by 50.5. To do the same thing here, we multiply the 20 by 2.4. We get a value. We raise the 20 to the power of 2, which is 20 times 20, and multiply by 0.13. Whatever we get here, we subtract the value that we get here, then we add 68. To do the same thing for this polynomial, we multiply the 20 by 0.648, we get a value here. We raise the 20 to the power of 2, which is 20 times 20, multiply by 0.111, we get a value. We raise it to the power of 3, which is 20 times 20 times 20, and multiply by 0.005, we get a number. So the number here will now be minus the one here plus whatever we have here plus 59. So we should be able to make substitution. So we can do something like that in Excel to work it out. So that if we have different value of x, you have when x is 5, when x is 10, when x is 15, x is 20, that is very long. Immediately you do one, then you can drag. We have examples similar to that under the Excel model. So now, when we are building linear optimization model, we need to identify the decision variable, which are the unknown value that the model seeks to determine. Under our operation research application, POM, we practice with a linear programming. So in those linear programming, the decision variables are our x1 and x2. Then the objective function was to maximize in that case. But when we got to the problem of transportation, the objective was to minimize. You can check it again, or if you have not done it, when you do, you take note. Then you identify all the appropriate constraints. Under the linear programming that we use, under the OR, the constraints are about 5. So those x1 greater than 0 is part of the constraint, x2 greater than 0 is part of the constraint. So those are the limitation, requirement, or restriction that affect the solution. The constraint may come from the practical or technological consideration or management policy. Then we write the objective function and constraint as mathematical expression, such as the one we did under the linear programming. Maximize, subject to, then list all of them out. Then we can also solve using appropriate tools. Most of the deterministic optimization model could be linear. So linear programming is an example of linear deterministic. We have integer programming, we have nonlinear programming. However, in practical situation, we will have a situation that involves uncertainty, and that will be with inherent risk. In such a case, stochastic model will be used. So it will involve probability in order to incorporate uncertainty. If an optimization model has uncertainty, we may first solve it deterministically by take one possible option. Then use Monte Carlo simulation to analyze the results by identifying different possible scenarios we can have with probability and possibilities, and now use Monte Carlo simulation to permutate all of them out and get the different results that are possible. We may now use the idea of optimization to select the best one. So that is the end of our discussion on analytical model.